I would like to introduce now my next speaker. It's Jochen Braun from Baumer, camera manufacturer. And Jochen is going to talk about how to boost inspection with smarter and more powerful vision components. Yeah. So Jochen, the floor is yours, and you get your clicker, of course.
Thank you. Good morning, ladies, gentlemen. First of all, the documents published before this event show another name. My colleague, who was up to last week absolutely healthy, has been hit and caught by the coronavirus. So for that purpose and reason, I've decided to step in and take over that talk here. In the next 20 minutes, I'd like to seed an idea with you. I'm not going to sell you a product. I try to, at the end of this talk, inspire you into a direction of where a standard camera can probably go in the future. So the title, Boosting Inspection Systems with Smarter or More Powerful Components, that's the goal I'd like to introduce to you. But beforehand, my name, Jochen Braun. I'm the head of sales for Baumer Optronic. Baumer Optronic is within a large group of the Baumer companies, the entity which is responsible for producing and designing cameras. We are based in Radeberg, Dresden, but as I said, we are part of that large group, more than 2,800 employees in the Baumer group. We are a sensor specialist, so there's really, like the headline says, a passion for sensors in all our genes and bodies as well. Headquartered in Switzerland, a business which is family owned and which also gives us a very, very solid, lasting background and financial base. The portfolio covers, as I said, not only cameras. We have a large portfolio of all different kinds of sensors, be it processing sensors, be it sensors in thermal environments, distance sensors, all that kind. A number of technologies we have in-house. Our production has capabilities from pick and place, PCB production, even going into the final assembly, naturally also many of our own tools. The whole IE is part of our know-how which we incorporate. Coming to the topic of that presentation. Normally, a computer system which we now, or which I stand for, utilizing a camera, is in many, many cases more than, if I'm correct, 45–50% is still cameras which are utilizing a PC system. So they are flexible. We can nowadays cover almost every application with it. We have full control of the functions, features. Quite often, customers can utilize their own IP, or they use libraries like we find them here on this event as well. And we certainly can, with the PC system, scale the performance. And the limits are the cost of the components. We also see that such a system can be quite complex. I will show some example later on. And we are also definitely requiring industrial engineering really to bundle that package, to combine those components. Just in the last presentation I've seen there are a number of components, tools, software you have to aggregate, and that's mainly an example for a PC-based system. On the other side, we also see here, we see this in other industries, smart camera systems, systems where the function of analyzing the data, capturing, analyzing, evaluating, and at the end delivering a result is in the smart camera system domain. High integration level, quite often just one robust housing, lower cost in comparison to such a big system, and, as I say, quite often really a robust design. However, we have limits. Often those functions in a smart system are, say, fixed, frozen firmware, frozen functionality, feature set is limited, and often, or in most of the cases I'm aware of, the performance is not scalable. You have to replace the sensor, use another model, but you cannot increase performance of a system. And if we look, however, at the applications, and I'm not going through all of them here, we all know them, you will realize that many of them have quite often not so high demand in overall function. They are moderate features, but however, we meet a wide range, often covered with a complex installation effort. We have to wire, we have to protect against environment. You see an oven example here where we have some heat challenges in addition. We have dusty environments and all this. And all this requires that all the components, starting from the camera as our domain, till the end, till the display, till the utility of delivering the results, all this requires a customization and actually a bundling at least. And now I come to the main topic of my presentation, and I'd like to ask the question, isn't there probably a link possible to aggregate the camera side a little bit more, still leave probably the evaluation on the PC side, but thinking about a little bit creative, how could we enhance, how could we deliver a camera with it's more integrated than probably just the lens, motorized lens, that's what we often know already, but looking probably at a next generation of an, we call it integrated digital camera. Still PC based, still utilizing the performance which I have on the PC side, but giving us advantages which we meet on the other side of the chasm where we have the smart camera solutions. So cost reduction is one of the goals, definitely with a device like you see it here on the right hand side could be achieved. An industrial design, robust, IP67 is a standard nowadays, so have this already from the shelf. Connectivity to make that device communicating with the environment, meaning it could be a switch, it could be an additional illumination, but already packing several functions into that camera, not just the sensor and the mounted lens. So the idea at the end is to have a, I'm a little bit shaky here to call it smart, but still a PC-based vision system or an edge system, which you will see in a minute how this topic could probably be developed. So what we try to achieve is a higher integration to simplify the system setup, no cables, no efforts of even lens adjustment. So optics included, an autofocus functionality included into that body. In our case, we have selected currently a mechanical lens focus, which is robust, which does not change over time. We have integrated illumination, so an LED ring segmented, actually 4 segments, is surrounding the lens, and all this built into one compact housing. In addition, and here I'm moving over to that smart part of sensor solutions, an OLED display, which helps us to read information on top of that device. For example, configuration data, for example, an IP address, but it could well be, at the end, a result. And the result could, however, also be indicated by the LEDs, the green LEDs, you see them on the picture, which are surrounding the lens, so that from a distance you can realize positive or negative result of a measure of an image being analyzed. And these LED indicators, even with the pointer for easier setup and installation of the device to really see where is the code, where is the area of my interest, all this integrated in that one housing. Going a step further, the question is, what do I do with the data? How do I transfer them? So we have in plan a gigabit Ethernet standard protocol, so it is still a PC-based camera which we have in front of us. Power and I/Os are common nowadays with many cameras, but here really going a step further to combine that device even with the Profinet or I/O link or an RS485 are potential possibilities we are seeing here. And last not least, I mentioned this already at the beginning, to have an industrial housing. So something really solid enough to be put into a rough industrial environment. And if I now go a little bit back and see, okay, how could such a device be integrated, now you see a regular common structure of an industrial system. The heart of the processing is the computer. Probably it should stay this way. It should keep its advantages of scalability, high performance, even customized algorithms, IP, all this. But on the other side, taking the camera today, which is as well controlling the illumination. Sometimes controllers are in cameras. In our case here, in that example, we have used an external illumination controller. But then taking the data from that computer and putting them into another environment, meaning into an SPS. I'm just short on the English word right now. But making sure that this system, as we see them today, modular with all the cable efforts, with a lot of components, with the tendency also, the question of mean time between failure, depending on the number of devices, also may hit us here. So trying to probably simplify this. And now I'm going into a mode where, now I hit 2 pieces. Can I go one back? Yeah. Now I'd like to trigger a little bit an inspiration. I'm not presenting a ready off-the-shelf product. We would like to seed an idea with you to look into this concept, think about the simplified device which I've just shown to you, but then seeing how could this look like if I just replaced the right-hand side where we've had the camera, the light controller and the ring light, just already replacing this one with this new and innovative device could be the first step to simplify your setup. Reduce cabling, compact size, quite an industrial device. If I now go a little bit further, we could even say, wait a minute, all that what's now here still on the left-hand side, the interfacing, Profinet, data delivery to a network, this could as well be put into such an integrated, call it a little bit smarter, I wouldn't like to call it smart camera, but putting it into an intelligent device. Meaning that even the Profinet or the IO-Link functionality comes out of that camera. And in that very simple picture here, you see that the PC only has the processing power, scalable, still IP, still high bandwidth, high volume if necessary in processing, but simplifying it all to have one neat box which takes over several of the system functionalities. And the next step, I think, is not even so much further. If I replace that bulky PC, high energy consuming, high space requiring to a device, what you see here. Actually, I have taken a picture here of a Raspberry Pi. Could be the minimum performance level, but still having that integrated camera, lens, optics, interfaces, protocol handling inside that device, and doing the processing just outside. Often processing also in smart cameras is a challenge, creating heat. So we probably only disconnect that processing part outside of that smart box, still keeping the advantage of scalability. It could be as well an NVIDIA device, could be a Jetson of different scales, still having that smart, call it integrated PC camera in our system. And so, in a summary, probably this has given you some inspiration. We'd like to talk about this new class of integrated camera. To my knowledge, we do not see many of those systems nowadays on the market. Cost reduction, remember, we've had reducing all the cabling, all the efforts to really package, mounting, quite simple, just one piece. Robust for the industrial use, in a solid IP67 housing by default. Connectivity built in, capabilities to add into their system, even additional protocols. And last not least, to mention the autofocus, the lens built into the system as well. Having a device which is robust against environmental influences, even robust against temperate misuse, people trying to adjust the lens and the vision system, we've all seen that. So all this wrapped up and packed into this integrated housing. And sure, having the capability to use the IP of the OEM customer, of the application, in such a still attached processing system. So now after just 50 minutes, I think I've almost reached the end of my talk here. So if this, sorry again, the wrong button. If this has somehow inspired you, do me a favor, come to our booth, talk to our colleagues about where such a device, small, neat, with additional, even hidden functionality, could be probably helpful for one of your devices in the future. At that part, I've reached the end of my details, and certainly there could be some questions. Thank you.
Thank you, Mr. Braun.